So the next part is types of hardness. So there are two types of hardness, temporary hardness or carbonate hardness or alkaline hardness caused by HCO3 minus ions. It is caused by which ions? HCO3 minus ions. This type of hardness is what? This type of hardness is the temporary hardness. So it is defined as the hardness due to carbonates, hydroxides, bicarbonates of calcium, magnesium and other metals. These other metals are again heavy metals like ferrous, manganese, aluminium. Correct? So calcium and magnesium carbonate. So when I talk about calcium and magnesium carbonate is CaHCO3 twice, magnesium MgHCO3 twice, CaCO3 MgCO3 is a carbonate. This is the bicarbonate. This is the bicarbonate. Carbonate, 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 bicarbonate, bicarbonate. Let's see how the hydroxides are formulated. CaOH twice, MgOH twice. So these are the hydroxide. So bicarbonates, carbonates, carbonates and hydroxides are formulated. Temporary hardness is mostly removed by mere boiling. You just have to boil the water and temporary hardness will be eventually removed. Where bicarbonates are decomposed producing insoluble carbonates or hydroxide. So the bicarbonates, they get decomposed forming insoluble carbonates or the hydroxide. So what do the bicarbonates form? The bicarbonates form either the carbonates or the hydroxides. So let's see the reaction. So for example, if it is CaHCO3 twice, this is what? This is calcium bicarbonate. When calcium bicarbonate is heated, that means you are boiling the water which is having calcium bicarbonate inside it. Heat means nothing but equal to boiling only. That means what happens? Carbonate will decompose producing bicarbonate will decompose forming carbonates or hydroxides. So calcium bicarbonate produces calcium carbonate. It forms calcium carbonate plus H2O plus CO2. Calcium bicarbonate will not form calcium hydroxide on heating. It will form calcium carbonate. Very, very important that calcium bicarbonate forms calcium carbonate. And when we talk about magnesium bicarbonate on heating, magnesium bicarbonate on heating forms magnesium hydroxide plus 2CO2. You release this heat. CO2 is released. So calcium carbonate forms calcium bicarbonate forms calcium carbonate on heating. Magnesium bicarbonate on heating forms magnesium hydroxide. Calcium bicarbonate, calcium carbonate, magnesium bicarbonate, magnesium hydroxide. Clear? So this is very, very important. These two reactions were very important. We have further reactions also in this to study. So I have erased this part. Let's see the further reactions. We have calcium carbonate or we have calcium bicarbonate or we have magnesium bicarbonate, and we are reacting it with the stearic acid, sodium salt of stearic acid. So this is what? This is sodium stearate. When we react it with sodium stearate, what do we get? We get C17H35COO twice Ca, or you can also have C17H35COO twice Mg plus 2NaHCO3. Clear about this? So, when salt of calcium bicarbonate or magnesium bicarbonate will react with sodium salt of stearic acid, we will get, that is sodium stearate. What will we get? We will get calcium stearate plus sodium bicarbonate or magnesium stearate plus sodium bicarbonate. This is the reaction. Okay. Next, when we have this, we will be revising once the whole process of temporary hardness. So the first reaction we saw was when calcium hydroxide it was heated. What was it done? It was heated. We got calcium carbonate plus H2O plus CO2 was released into the atmosphere. Second reaction, when magnesium bicarbonate was heated, we got magnesium hydroxide plus we got 2CO2. And the third reaction we saw when calcium bicarbonate or magnesium bicarbonate reacts with sodium salt of stearic acid, that is nothing but sodium stearate, we will get either calcium stearate or, so this is calcium stearate, or we will get C17H35COO twice Mg magnesium stearate plus sodium bicarbonate. So these are the three very important reactions. Calcium bicarbonate will give calcium carbonate and magnesium bicarbonate will give magnesium hydroxides. So next type of hardness under this is permanent hardness or the non-carbonate hardness or the non-alkaline hardness. So why is it called non-carbonate hardness? Because it will now include chlorides and it will include the sulfates. So it is called as the non-carbonate hardness. It is due to the presence of dissolved chlorides, sulfates and nitrates of calcium, magnesium, iron and the other heavy metals. Permanent hardness is not destroyed by mere boiling. So if you heat the water having permanent hard water, having permanent hard water, the hardness will not vanish. The hardness does not vanish. Hardness does not vanish. Only temporary hardness can be removed by mere boiling, but not the permanent one. It requires special chemical treatments for the removal of the hardness causing salts, such as internal conditioning or external treatment. Now what are these treatments? These treatments are the ion exchange process. So one is the ion exchange process. Then we have also learned about zeolite permuted process. Zeolite permuted process. So these are the various processes which are used for treating the hard water having permanent hardness. So for permanent hardness, the equation goes like this. CaCl2 is given or MgCl2 is given. What is given? CaCl2 is given or MgCl2 is given. Now we will react this by again sodium stearate. We will react this by sodium stearate. What will you get? You will get C17H35COO twice displacement reaction. So you will get Ca twice Ca, or you will get C17H35COO twice Mg plus NaCl. Okay, so this is the reaction number 1. And what is this is a simple displacement reaction, correct? This is a simple displacement reaction, correct? And you have one more reaction. What is that? This is for chloride. Now I will take sulfide. So let us take sulfide and check. So I will take CaSO4 or I will take MgSO4. I will react it by 2 C17H35COONa. So what is this? This is nothing but sodium stearate. This is nothing but sodium stearate. I get C17H35COO twice. Again simple displacement. So this part will add up with Ca, or this part will add up with my Mg, correct? And what remains is Na2SO4. What remains is Na2SO4. So these two reactions are possible. One is with chloride and one is with sulfate. So we won't take nitrates into consideration because we have sulfates and chlorides only. If we want, we can also see with nitrates. There is no problem as such. So let's see with nitrates. We have CaNO3 twice. The problem is this, okay? MgNO3 twice. Again, I will put here 2 C17H35COONa. What will I get? C17H35COO twice. We will get Ca, or we will get C17H35COO twice Mg, plus we will get sodium, nitrate. Clear about this? Okay, so this part is over. Now next thing which we are going to check is what it is. Very simple. It is the difference. It is the difference between, we are going to see, so we have already seen the permanent hardness and the temporary hardness. Reactions concerned with the permanent hardness and the temporary hardness, we have seen that the calcium bicarbonate will give calcium carbonate and magnesium bicarbonate will give magnesium hydroxide. We have also seen when they react with sodium stearate, what kind of reactions are produced. Now we are going to see the difference between temporary hardness, between the temporary hardness and the permanent hardness. So what is the difference between temporary hardness and permanent hardness? Let's quickly check. So first point says that temporary hardness can be removed by simple techniques. This is a very, very important difference. And this type of hardness cannot be removed by simple techniques. Agreed or no? Obviously. Why? Because for this we require chemical processes. Understand, we were talking about the ion exchange process and the zeolite process. All these take place in the industry at a large scale, at a chemical scale. For temporary hardness, we just require mere boiling. So isn't it a simple technique as compared to zeolite process and ion exchange process? Obviously, boiling is simple. So it cannot be removed, permanent hardness, whereas temporary can be removed. Second point says temporary hardness is due to bicarbonates. We have bicarbonates, carbonates. So we say that this is a carbonate hardness because we have bicarbonates and we have carbonates which are causing this hardness. We also have hydroxides, but in most cases it is bicarbonates and carbonates. Whereas for permanent hardness, it is because of chlorides, sulfates, nitrites. So this is a non-carbonate hardness. Agreed? This is a non-carbonate hardness. So we understood the first point. We also understood the second point. Let's see the third point. This hardness is the alkaline hardness. Now, why is it said as the alkaline hardness? So, you remember that in the first lecture, we said that alkalinity is majorly because of bicarbonates and the carbonates. So there was a point which said that alkalinity is because of the bicarbonates and the carbonates. This is the major chunk. So therefore, temporary is also called alkaline hardness. Whereas when I talk about permanent hardness, it is called as a non-alkaline hardness. So it is called as a non-alkaline hardness. Temporary hardness can be removed by boiling. Permanent hardness cannot be removed by boiling. This we already know. Correct? So my next point says that for the temporary hardness, it will deposit, what it will do? It will deposit the salt of carbonate or bicarbonate. Okay, it will deposit these salts, and what releases is CO2 and H2O will release. Whereas permanent hardness does not form any deposits. What does it form? It forms scales, you can say. So what does this form? This forms the deposits. That means it will deposit down in a container. It will deposit. But this will not deposit. This will produce scales in the clear water. Therefore, it will be difficult to handle the permanent hardness. Clear about this? Okay, so let's see what have we done. We have done the difference. We have also done what is permanent or non-carbonate. We have also done what is temporary or the carbonate hardness. The reactions which says carbon, calcium bicarbonate, calcium carbonate, magnesium bicarbonate, magnesium hydroxide, then how it reacts with sodium stearate. Again, this calcium chloride. We saw calcium sulfate. We also saw calcium nitrate, magnesium chloride, magnesium sulfate, magnesium nitrate.